solving modulus equations. That was exactly the same. Sorry? No one understands it, but I'm not really that fast. If the modulus of a function equals k, then f of x equals plus or minus k. Or the other way you look at that, which might help you, is that plus or minus f of x equals k, which we can transfer that plus or minus across to the k. So what we're saying here is that the absolute value of positive f of x is positive f of x, and the absolute value of negative f of x is positive f of x. So that works. This is how we're going to solve equations. If you're not quite sure on that notation, then I'll show you examples. You'll see it through the examples. So let's consider, first of all, a solution graphically. If we were to solve x squared minus 3x equals 2, but with the modulus there, if we sketch that modulus function, which I've done down here, you'll see that the negative components flip up. So not only do we get the solution, which is a solution to x squared minus 3x, where it's positive, and that's the first one and the last one, but we also get these inside solutions. And they're the solutions that occur when x squared minus 3x is negative, or when x squared minus 3x is equal to negative 2. And then we flip it up in the graph. So the solutions to modulus equations can be done quite easily just by saying, well, x squared minus 3x is either 2, which will make the modulus of 2 equal to 2, or x squared minus 3x is negative 2, which will make the modulus of negative 2 equal to 2. So this is the easiest way to go about it. The reason I just talked about this with somebody else here, Xander mentioned earlier, what about if we just square both sides? Will it work? So here's a simpler one, a linear equation with a modulus. The modulus of x minus 3 equals 9 is in your textbook. We could square both sides, gives us x minus 3 squared equals 9 squared. And then if we retake the square root, we get x minus 3 equals plus or minus 1, which is what we're saying anyway. So you can either take the square both sides view or the just realise the modulus has to be plus or minus view. Either works pretty much exactly the same. And I'm just going to do a couple of examples with you. I haven't got a linear example. I'm hoping that you'll be able to deal with a linear example based on our A and B examples here. So let's start with example A. The modulus of x squared minus 10x is equal to 21 gives me these two separate equations. Either x squared minus 10x is the positive version of 21, or x squared minus 10x is the negative version of 21. That's the only way that modulus can work to give me 21. If x squared minus 10x is equal to 17, doesn't work. So they're my two equations, which means I'm expecting to have possibly 4 real solutions. I might have 2 real solutions and 2 complex solutions. I might only have 3 real solutions if I've got one that just touches. So there's different situations here. Be open to expectations. I'm not going to do it in this topic. You won't get complex solutions. But in your IA2 exam, there's no reason why I couldn't give you one that looks like a modulus question, but it's actually got complex solutions. In fact, if you've got a modulus question, it would have to have complex solutions because this is Unit 2 work. So in an external exam, they might give you something like this, where you're actually relying on complex number work within a modulus context. So I solved both of these separately. X squared minus 10x minus 21. I just need that x there. Equals 0. Can I factorise that? I don't think I can. But this one over here, 10x plus 21 equals 0. I can factorise that as x minus 7, x minus 3 equals 0, and x is equal to 3 or 7. But I can't factorise this one, so instead I'm going to go to the quadratic equation. If you're in a tech-free exam, just use your calculator. No problems there. Tech active, good point. If you're in a tech-free exam and you're using your calculator, big trouble. I'll just drop it down a little bit more. Negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 21 all over 2. The most simplified version of that is 10 plus or minus, in fact, I might even simplify it more, 5 plus or minus, that's 100 plus 84, so 184 over 2, which I can simplify more because 184 is what? 45, 46. So it's 5 plus or minus 2 root 46 over 2, which is just root 46. And they're my solutions. Now, realistically, in specialist maths in particular, but math methods as well, unless the question actually asks for it, I'm very happy with exact values. In fact, I'd probably prefer exact values. So in maths, we deal with exact values. Once you take the math solution and apply it to context, to science, engineering, economic context, then you might round it and use that rounded value. But for now, in maths, so unless it's asked for, that's fine. Are there any questions on that? If I sketch that, I'd have 4 solutions based on that reflection on a sketch, and that would work for me. Question B, actually I think ends up being a little bit easier. So I've got 2 modulus of x equals 16. I do have to be a little bit careful. So there's 2 ways I can do this. I'm going to show you both of them. The first way, number 1, is I can recognise that either 2 to the power of x equals 16 or 2 to the power of negative x equals 16. And this is true if x is less than 0. This is true if x is greater than 0. So I can do it like that. And that gives me x equals 4. And is there a solution to that? X equals negative 4. That works. 2 to the power of negative 4. That works. So I could go through and solve it that way. The other way I could do this, example 2, method 2, is I could get 2 modulus x equals 16, rearrange it to get the modulus thing by itself. So I'd now write that down as the modulus of x equals log base 2, 16, which equals 4. And then I'd say, if I go back to this rule up here, the modulus of x, or the modulus of fx equals k, then fx equals plus or minus k. So that tells me that x equals plus or minus 4. So for the modulus of x to equal 4, x must be plus or minus 4. Yeah? 2 ways to solve that one. And again, I don't really care which way you do it. I personally tend towards the second way. Easier because the first way does involve rearranging the same thing twice. So I would tend towards the second way, but it's up to you. 2 modulus x equals 17 is pretty much the same question. I don't really know why I put it in here, but let's do it now because it's there. I'm going to do it the second way using my method. It gives me modulus of x equals log base 2 of 17. And therefore x is equal to plus or minus log base 2 of 17. I think I put it in here because the original example was a good example because you can work it out just logically. And so 2 to the power of what equals 16? Oh, 4, okay. Well, this one here you can't work out logically. And I'll put down again, this is an exact value. Logs are exact values as well, so I can leave it as that. But I'm going to go and just evaluate it as well. Log AB 217, 4.08, so plus or minus 4.09 actually. Remember that? Some of you didn't remember this, or maybe it was in math methods, I can't remember, but when you round 2 decimal places, unless you're told otherwise, is the standard. So just keep that in mind. Even if the answer is 4.1, you put 4.10. We expect that will have a bearing on your external exam, so get used to doing that. Are there any questions on this? Okay. The last thing I'll say is if you are on your calculator, thank you for bringing this to my attention, Alzani, and reminding me, and you want to do the absolute value, particularly in a graph sense, like have you got a number, negative 18, and you're doing the absolute value in a calculator of that, I'd be disappointed. But on here, down the bottom, you have your math menu inside ABS. That's the absolute value, which is another name for the modulus function. So ABS gives you the thing, and ABS of negative 17 is 17.